Well, when I was growing up, I was really a fan of Kurt Vonnegut, and Kurt wrote some remarkable works. And I later learned that most of the fodder for that work came from the work of his brother, Bernard Vonnegut, who was a scientist at GE under Irving Langmuir, the lead scientist there. That work was focused on the production of ice crystals at elevated temperature using a compound called silver iodide.
I would like to take you into the laboratory and show you a few of the experiments that led us to our outdoor experiments in converting clouds into snow. These are some which I photographed that were formed in the laboratory. This is a picture of the first cloud that we seeded back last November. Putting dry ice from a small dispenser in the bottom of the plane, under many conditions of course, full-fledged snowstorms will be produced in this way. Nature at last has permitted to do a little something about the weather.
These were something that scientists had worked on and developed through the 1940s, 50s, and 60s, and were likely being deployed even today. The research done by Vonnegut and Langmuir coincided with changes in our sky. As these programs, or at least this type of research, increased, the skies started to change. My first real observation of those changes and real awareness of it came, I was looking up and saw patterned skies of these trails that were being laid out by planes, then developing into confluent layers that would drift perhaps hundreds of miles, changes the weather, changes the temperature around you. Also, the light intensity and the quality of light was changing. It was funny that there was not really a lot of published literature on this material. There had been some governmental reports that I had dug into. There was some evidence that this type of research was being conducted. And in fact, there was a presentation that was given where Dane Wigington asked some questions about the materials that they were discussing and their possible role in weather modification programs.
Numerous air quality studies, including from CARB, California Air Quality Resource Board, have named submicron-sized particulates as being particularly harmful for human respiration. Through all the discussions today, I have not heard any mention of this fallout, and has this been studied, and also the effects of a highly reactive metal like aluminum on toxifying soils and waters?
The question is, what would be the effects of these materials on human health if they came down into the stratosphere? In particular, small particles and aluminum. In our climate model, we looked at how much additional acid rain, acid snow you would get from the sulfur coming out of the stratosphere if you did it at a rate of 5 megatons per year or 10 megatons per year of sulfate. And it turns out that amount is so much smaller than what humans put into the troposphere on an annual basis by burning fossil fuels as a byproduct. Even in pristine areas, the soil would have a buffering capacity and it wouldn't be harmful.
So the collaborators in my working on the aerosol scheme are actually folks from Carnegie Mellon who focused on human health impacts. And while we haven't published it, that was the very first thing we did, was do the order of magnitude calculation in federal pencil and paper, but with an expert on human health impacts about whether there could be an issue. And the answer is no, clear-cut no. So for the numbers of particles burning the stratosphere are so tiny compared to the loadings on human health. There are other things that worry me a lot, like the rain on these particles in the upper troposphere when they might affect high clouds. And for aluminum or other particles, there are a lot of toxicological things that need to get looked at seriously. But if you're just thinking about the sheer number of particles and the human health impact of small particles, the answer is, well, we haven't published it. That was the first thing we looked at with some of the leading experts who do epidemiological research on human health impacts, and it's not even close to huge.
So 10 megatons of aluminum dumped into the atmosphere will have no human health impact.
So let me be more careful here. We're to separate out the toxicological, but so the aluminum we've only begun to research and published nothing. The question I was asking was purely about particle number density. So what we did is we said, we looked at some global estimates now. We have of aerosol global estimates that were built for epidemiological purposes of the global loading of aerosols in terms of health impacts. And we said if we added on top of that what we're doing from the stratospheric aerosols, could it have any impact? And the answer is that was totally irrelevant. But that was just on particle number. we haven't done anything serious on Illumina, and so there could be something terrible that we'll find tomorrow we haven't